So today we're going to start chapter 5. We're going to look at, which is a graphing chapter, 5.0, background to graphing, how to plot, the x and y coordinates, how to create a table of values, how to read a graph. Yeah, so then chapter 5.1, we'll look into a little bit more detail about relations and graphing. So we'll look at things of how does a constant slope look like, an increasing slope, how to interpret a graph with different slope values and that sort of thing. So let's just jump into it. All right, so this is a copy of the notes that you should have on the class notebook. And first section 5.0, again, it's not in your textbook. This is just a quick review of the background to graphing section. Interpreting and generating graphs of data. Okay, the graph shows the relationship between earnings and time. You can see earnings here is on the y-axis. Y-axis is a vertical axis going up and down, and the x-axis is the horizontal. Okay, that's always true. And what else is always true is going to be time. If you ever have the value time, plotting against something against time, is going to be on the x-axis. So we're going to talk about independent values in a future section, but basically the independent value is always going to be on the x-axis. All right. And then the dependent value, earnings, depends on time. So how much you make depends on how much money, how much you make depends on how many hours you worked. The time doesn't depend on earnings, right? So anyways, so that's for another section, but for now, it says use the graph to help you complete the table. So all you do is the x values are on the left side here. You can see the y values on the right side. So at 2 here, I'm just going to go to 2 on the x, and I'm going to go up until I hit the line where it intersects. So once you hit this point, you stop and you go to the left until you hit the y-axis, and you can see it's 30. So when time is 2, earnings is $30 here. So here we're going to do the same thing but in reverse. Since we got the y value here, earnings is 60. We're going to go to the right until we hit the slope, and then we go down at that point, and it's 4. Okay. Now you can do the same thing for 6 hours. Go up and go across, and it's going to be 90 and 105. So this is 90. This is 120. You know, it's going up by 30 for every 2 squares. That means in the middle has to be 15. So this is 105 right here, and go down, you get 7. Okay, so there you go. What are the coordinates where the graph intersects the vertical axis? So where the graph hits the vertical axis, you see the vertical axis is up and down here. So the slope here, it doesn't hit it until this point here, the 0 point, which is just 0, 0. And then just a note, when you write it in this form, we're writing it like x comma y. So the first number is the x value, which is in this case is still 0. The second value is the y value, the up and down value, which is 0. Okay. And just note that when you're talking about y, it's all positive numbers going up. Below 0 is going to be negative numbers going down. On the left side, negative numbers for the x, and the right, all positive numbers. And that's just like the convention that you do in math. Okay, we could have labeled it a different way, but this is what everyone does. So what is the meaning of this point? Okay, so what does 0, 0 point mean in terms of like the question here? So if 0 hours worked, you get $0, 0 earned, right? So no one gets money for working no hours, right? Okay, I tried to make a joke, but I didn't like it, so I cut it out of the video. Okay, so now we're back. Let's go to example 2. You're walking to school at a rate of 100 feet per minute. Complete the table of values for this scenario. So here we got to create the table of values, the x values, the y values, right? So let's write down x and y. Okay, and they have our rate, right? How fast the slope is going up or down. So 100 feet per minute, right? So you know that in 1 minute there is 60 seconds in a minute, right? So if in 60 seconds, I know we could just convert all this, but I'll just do it in our head right now because the idea is to plot it. So 100 feet per minute, that means in 30 seconds, in half a minute, there's going to be half the distance. There's going to be 50 feet, right? So at 1 minute, as there you tell you, is 100 feet. At 90 seconds, a minute and a half, you're going to get 150, right? And 120, so in 2 minutes, you're going to double this, multiply by 2, which is 200. So that's what I would do right there. Complete the table of values for the scenario. Okay, so now we're just going to graph this. So we have our x value. So when x is 30 seconds, and these are, note, these are minutes. So 30 seconds is 0.5 minutes. Y value is 50, so right here. So I'll put a dot. And at 1 minute, we got 100, right? At 1 minute 30 seconds, we got 150, and at 2 minutes, we got 200. Okay, there we go. So when you plot it, and then you can connect the dots, right? So here, you should be using a ruler. I don't have a ruler on me right now, but use a ruler, otherwise it's gonna look wobbly. Okay, there we go. Okay, and I'm just gonna plot an arrow here. Okay, another note is this arrow here at the end of the line, it means it continues on, keeps going, right? So in some scenarios, you're not going to use the arrow. So if it's just at a certain point of time, then you don't really need it, right? So we'll talk about that in more detail later as well. Okay, let's keep going. Okay, you are walking to school at a rate of 150 per minute, 150 feet per minute. Complete the table of values for the scenario. Okay, so same sort of thing. So if it's 100 feet per minute, right? And then 30 seconds is half, so we're just going to divide this by 2, which is 75. 60 seconds per minute is 150, so 60 seconds is 1 minute, so you can just write down 150. And then we're adding 75 here to get 225. And then finally, at 2 minutes, 120 seconds, it's a double, right? So this is 300. Okay. Complete the table of values. So we did that on the same grid as number 2. Graph the new walking data. Okay. So I'm just going to use a different color, I guess. I'll use green. So at 30 seconds, right here, we got 75. Okay, so we're actually up here somewhere. Okay. And then at 60 seconds, we're at 150. And then at 2 minutes, oops, I skipped 90 seconds. And 90 seconds is 225. Right about here, I think. This is 250, so 205 in the middle here. And then finally at 2 minutes, we got 300. So way up here. There we go. Okay, so then you can connect the dots using a ruler. There you go. Okay, so that one's done too. Okay, describe the differences between the two lines on your graph, number 2 and 3. So what's the differences between this? So we'll call the green one number 2. Or we could just call it green actually. So green slope, we can see it's steeper, right? So why is green slope steeper? So it meaning the rate is faster. The rate is faster. And what is that in plain talk? Rate being faster, and we're talking about walking speed. So I guess you could say walking speed faster for example 3. Something like that. Oops, you can't even see what I wrote, but here we go. Green slope is steeper. Green slope steeper, meaning the rate is faster. Walking speed faster for example 3. So you can see that. The more flat it is, meaning the rate isn't changing as fast, meaning that the speed in this case is staying constant, or or close to what the original speed was. All right, so let's move on to the next page. Okay, so next page of 5.0. The graph is a visual comparison of two quantities. So let's review what we know about coordinates and graphs. So you should know that, first of all, the graphs are divided into 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3 in the left, bottom left, and Quadrant 4. So I'll label that right now. Okay, so this is important to know because, if someone's asking you which quadrant, what area you're in, or try to communicate your graph. Okay, quadrant, and then quadrant 3 in the bottom left. Spelling is wrong. Quadrant 3. And you use Roman numeral letters. Quadrant 4. I think 4 is like that, right? Alright, so in quadrant 1, you notice that the x value is to the right, y value is upwards in this area, right? So this is going to be positive section for both x and y. And remember, it goes x, then y. Okay. In this quadrant, on the left side, you notice that x is negative, and the y is still, it's going up, so it's positive, right? So in that quadrant. In quadrant 3, you're going down, so x is negative, and you're going to the left, so both x and y are negative. And then finally, in quadrant 4, you're going to the right, so x is positive, and y is going down, so it's negative. Okay, so that's all you really need to know about quadrants here. So, for example, someone says, plot point, for example, let me write it in red, 0, 3. Okay, so which quadrant is 0, 3 in? So you go in the graph, x is 0, right? And then 0, 1, 2, 3. So this is just on the y-axis between quadrants 1 and 2. So I guess it's not really technically in either quadrant, but it's on the y-axis between the two quadrants. Or if you have point, let's do another one, -5, -5. And already I know that, oops, negative. Both numbers are negative, so I know it's going to be in the bottom left somewhere, right? Negative. So -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here, and you should also label your points as well, -5 and -5. And this was 0, 3. Okay. And how did I know each point was 1? I didn't really, because I didn't label the axes, right? So I just assumed each box is 1 digit, but we could have had each box be 10 digits or 100 digits or a million digits, right? It depends on what we need to label the axes as well. All right, so let's go on to 5.1. Actually, before we go to 5.1, if you want to, I'm not going to do this, but if you want to practice just labeling points, there's a little exercise here. And I think it makes a pictures, some kind of picture, maybe like a dog or a bunny or something. So if you have time, you can plot this out and you get some kind of picture. Okay. All right, now let's move to 5.1.